Oh my gosh, I'm on the air. Camera, action. Hey, this is hard because look, I'm thinking I'm moving my head that way. I mean that way, but it's really moving that way. Now, oh, okay, now I got it right. Because everything's just opposite. I'm picking my nose here, but I think I'm picking it here. Here are the answers for directed reading B. This would be the section on compound. Which substance is a compound? Salt. You know that. Compounds made of elements. What kind of substance is composed of two or more elements that are chemically combined? What you want to know is that they are chemically combined. Compounds are chemically combined. Okay, they're not mixtures. The mixture is the batter. The compound is the bread. My son hates it when I do this stuff. I'm kind of hating it too. But how do the properties of a compound compare with the properties of the elements that form it? They're always different. The compound is completely different from the elements that form it. The ratio of elements in a compound, number 4, they are always in a specific mass ratio. Just remember that. When you get older, you'll understand it. Number 5. No, I have not purchased the mod to Modern Warfare World at War. Cool. When I do, should I let all my classes know, as I'm still recording and they're hearing all this? Want to see my son? He's running up the stairs. Wait. I know it's so funny, but they'll laugh. If they don't, they'll throw things. Properties in compounds. Which is true about compounds? Bye. I will pay attention to you shortly. Let me just finish this. Each has its own physical properties because it doesn't want to be the elements it was. 6. Compounds versus elements. I like the second movie. First movie was a little slow. But Compounds versus Elements 2, I found was very exciting. Okay. We are able to eat sodium and chlorine as a compound because when they have that chemical reaction and change into table salt, otherwise known as sodium chloride, compound is harmless. All right, now the next one is breaking down compounds. The compound that helps give some drinks fizz is called carbonic acid. When you open a soft drink, the carbonic acid breaks down into carbon dioxide and water. Okay, so you start with carbonic acid, and then it does not like oxygen coming in and destroying its family life, and it becomes carbon dioxide and water. So that's why a soda gets flat. More water gets into it because it loses that acidity, which makes it bubbly. The only way to break down a compound is through a chemical change. That means, like, try to destroy it. Like, you put hydrochloric acid on chalk. It reacts with the acidity, get bubbles, and it breaks it down. Just like when rust reacts with oxygen. Iron reacts with oxygen. Sunday. Come on, guys. Give me a break. I'm trying to rush to get to the Eagles game. So anyway, iron reacts with oxygen. It's the only reason I grew this little beard here so I could pull it. You know, girls like to take their hair and kind of like eat it sometimes when they're nervous. Guys, you got to okay, that's enough. Compounds in your world. Actually, it's not in any of our worlds. Okay, I've never seen aluminum oxide. I have no idea what it looks like. But When you break that down, you can get aluminum. That's number 10. B. For those of you having trouble following along, that was answer to number 10 is B. 11 is A. Because I know from studying my environmental science and learning about earth and soil, bacteria can form compounds from the nitrogen in the air. And then it helps pea plants and other plants grow or utilize the nitrogen. What type of compound do plants and animals use to make proteins? I think it's nitrogen, which is D. I better check on that. Could be ammonia. Anyone want to argue? Please contact 555-1212. What do plants use during photosynthesis to make carbohydrates? They use carbon dioxide, which is B, because plants give off oxygen. Now for the important stuff. Mixtures, because we're going into mixtures. Now, this is a teaching moment, so don't expect me. Okay, I'll give you the answers first, and then I'll teach. Here we go. Number 1 is mixture. Number 2 is compound. Number 3, identity. Number 4, physical. Number 5 is distillation. Number 6, magnet. Number 7, centrifuge. Number 8, filter. We're going to do an experiment for number 8. We're actually going to put salt and sulfur together and even some water. We're going to put it through a filter. We're going to separate all the sulfur, and then we'll have salt water, and then we're going to boil off the water, and we'll just have salt. See if it works. Crude oil. If you use distillation, you got to look at your book. It shows a system where you have you're making use of the boiling point, and that's why the boiling point and melting points of elements and compounds are very important, because if you boil crude oil long enough, it separates itself into gasoline and kerosene. Gasoline's over here, kerosene's over there. Doesn't matter which way I point. Is there a lag from when I'm pointing? But this finger is already over here before it gets there, because this camera's low. Okay. We're at 8:48. Can you believe 8 minutes went by so fast? What else do I want to tell you? Mixtures. Mixtures are like batter. Nothing, it's like sand and water. Butter and flour. Leaves and kids. That's a mixture. Pizza with pepperoni and mushrooms is a mixture. You can pull off the mushrooms, pick off the pepperoni. Salt and water. That dissolves without a chemical change. But you can get back to salt, so it's a physical change. Now how about when you take the powdery stuff called saccharine? It's like a mixture of sand and gravel and Portland cement, and you mix it with water. And if you let it set, it gets hard. That, my friends, is a chemical change. That, my friends, is no longer a mixture. That's a compound. So there are little things that can foul you up, but for the most part, In a mixture, the identity of the substances doesn't change. So you still got butter in there with your flour and baking soda and sugar and salt. They're all the same. Heat it up, and you got a completely different animal. What else? Distillation. I talked about that for oil. Basically, I don't have the supplies, so I cannot boil off. I can't do distillation for you. I can show you pictures, and hopefully there's something on the web. But it's really cool because you should know this. You know why? Because if you're stuck on a raft in the middle of the sea and you happen to have a Bunsen burner or some kind of mechanism where you can heat up salt water, you can collect. What you want to do is once the water boils, it goes in the gas. It's still water, it just makes a lot of gas. So you run it through a tube, and as it goes through the tube or a hose, it starts to cool down and becomes water again. That water is fresh because the salt doesn't have the same boiling point or melting point. And so the salt's left behind. And then you got fresh water to drink. And then you can save the salt and put that all on all those flying fish that jump on your boat. And you could, you salt the fish. That helps kill bacteria. Also makes the raw fish taste better. The only reason I'm mentioning this is because there's an article I just posted on the wall. Because I'm starting a wall of science of science articles, anything that has to do with what we're studying. So this isn't all just like stuff that somebody made up just to torture you. Okay, that's all the time we have today, folks. I'm sure this was boring as watching grass grow, or I don't know, if you live in the city, I guess the concrete crack. Maybe I shouldn't have said crack in the city at the same time. Now I'm probably going to get yelled at. It's hard to be politically correct. And what does that mean? Ask Ms. Baptiste. That's all for now. Sorry to see you go, but I gotta. Bye.